The question is the components of pure shear strain in a shear material are given in the matrix form epsilon is equal to 1, 1, 1 minus 1, 2 by 2 matrix. Here trace epsilon is equal to 0 given P is equal to trace epsilon power 8 and Q is equal to trace epsilon power 11. The numerical value of P plus Q is this question from engineering mathematics from the topic linear algebra eigenvalues. Solution. Trace of a matrix is sum of the diagonal elements. 1 plus minus 1 is equal to 0. Okay. So to find trace of epsilon power 8, epsilon power 11, let us use the properties of eigenvalues. Trace of a matrix is equal to sum of the eigenvalues. So that if you find first epsilon matrix eigenvalues, then we can use properties lambda power 8 and lambda power 11 are the eigenvalues respectively P and Q. That is easy. Instead of normal multiplication epsilon power 8 matrix multiplication. Here matrix multiplication will take more time. So first find characteristic equation. CHEQ characteristic equation is determinant subtract lambda from the diagonal elements of the given matrix only 1 1 minus 1 minus lambda equal to 0. So AD minus BC. So this is A plus B into A minus B, A square minus B square after taking minus here common. Then that A square minus B square with minus will become lambda square minus 1 minus 1 is equal to 0. Lambda square minus 2 is equal to 0. Lambda square is equal to 2. Lambda is equal to minus root 2 comma root 2 are the eigenvalues, that is E values means eigenvalues of matrix epsilon. That is this one. Okay. Of matrix epsilon. Okay. Now implies eigenvalues of matrix epsilon power 8 are minus root 2 power 8 comma root 2 power 8. That is minus 16, plus 16 comma minus 16. Okay. 16 comma 16 repeated eigenvalues. And eigenvalues of matrix epsilon power 11 are minus root 2 power 11 comma root 2 power 11. That is minus 32 root 2 and plus 32 root 2. So therefore, matrix, it is not matrix P is equal to trace epsilon power 8. That is trace of a matrix is sum of the eigenvalues of the matrix. So 16 plus 16, 32. Q is equal to trace epsilon power 11. That is sum of the eigenvalues of the matrix epsilon power 11. So will become 0. All these are using properties of eigenvalues. So P value 32, Q value 0. Therefore, numerical value of P plus Q is 32. So the answer is 32. This is end of the question. The question is, let Y be a non-zero vector of size 2022 into 1. Which of the following statements is are true? A, B, C, D, 4 statements given. This is from engineering mathematics from the topic linear algebra. Subtopic rank eigenvalues. Solution. So this is a column vector of higher order, that is 2022 rows and one column only. It's a big size. So let us take a small size 2 cross 1. The same result we can prove when Y is a size of 2022 into 1. Suppose Y is equal to a 2 cross 1 matrix whose entries all are 1. I'm taking this. Be a at least one element is not equal to 0. Such a vector Y is non-zero. Be a non-zero vector of size dimension, that is 2 cross 1. Okay. Then let us check that one by one statements. Y into Y transpose. Column vector transpose is row vector. So 1, 1 multiplied by row vector 1, 1. Matrix multiplication using that, you will be getting 1, 1, 1, 1. First row into first column, first row into second column, second row into first column, second row into second column. All are equal here, which is a 2 cross 2 matrix. Okay. So, and this is a symmetric matrix. First row elements equal to corresponding elements in the first column. Elements in the second row is equal to elements correspondingly in the second column. Okay. So, which is a symmetric matrix. Okay. So, this is transpose satisfying A transpose is equal to A, like that condition. Okay. Now, so statement A is true. And regarding invertible means inverse exists, that is non-singular matrix only. And determinant 1, 1, 1, 1 is equal to 1 minus 1 is equal to 0. So therefore, Y into Y transpose is singular matrix. Okay. Implies Y into Y transpose is not invertible and rank of Y into Y transpose less than 2 using properties of rank. When rank of is, that is, if where n is equal to 2 is the order of the matrix Y into Y transpose. Okay. So already Y into Y transpose matrix is singular. So rank of its matrix, rank of that matrix is less than its order. So less than 2 means either 1 or 0. Already this is a non-zero matrix. This is a non-zero matrix. Okay. So non-zero matrix rank is always greater than or equal to 1. So implies rank of Y into Y transpose is 1 but not 2. But not 2. Okay. So statement C is not true. Similarly, statement D is not true. Now let us find the eigenvalues of Y into Y transpose. Already singular matrix means one of the eigenvalue is 0. And using properties of eigenvalues, you will be getting another eigenvalue 2. Okay. Or you can find the characteristic equation of matrix Y into Y transpose is determinant 1 minus lambda 1, 1, 1 minus lambda. You can use the two properties, singular matrix eigenvalues and sum of the elements in each row is equal to same. So that value is an eigenvalue. of that matrix. Because it is of 2 by 2 matrix, you will be getting only 2 eigenvalues without finding characteristic equation also. So this simplifies to 1 minus lambda whole square minus 1 is equal to 0. Lambda square minus 2 lambda is equal to 0. So solving, you will be getting lambda 0 comma 2 are the eigenvalues of the matrix y into y transpose. E values means eigenvalues. Okay. Now y transpose into y. So column matrix transpose becomes row matrix. Into this y means column matrix. So you will be getting first row into first column, one element only, 1 into 1 plus 1 into 1, 2. So this is 1 cross 1 matrix. So implies the eigenvalues because every 1 cross 1 matrix, the element itself, the one element itself is the eigenvalue of that matrix. Eigenvalue of y transpose into y is 2. Okay. The eigenvalue, not values. Why? It is a 1 cross 1 matrix having only one eigenvalue. So this 2 and this 2. Okay. This 2 is also an eigenvalue of y into y transpose. Therefore, y transpose y matrix having an eigenvalue is an eigenvalue because y into y transpose we have two eigenvalues. An eigenvalue of y into y transpose. Okay. Similarly, we can prove that similarly, see this is similarly AB are true. Okay. If we consider y is a non-zero vector of dimension 2022 cross 1. Okay, finally, therefore, A, comma, B are only true. Similarly, the statements A, comma, B are true if y is a non-zero vector of size 2022 cross 1. Okay, this is end of the question. Answer A, B. The question is, a pair of 6-faced dice is rolled thrice. The probability that the sum of the outcomes in each roll equals 4 in exactly 2 of the 3 attempts is. This question is from engineering mathematics from the topic probability and statistics, subtopic random variables or general method. The solution is so here n of s, that is total outcomes in the sample space where s is the sample space. Rolled 6-faced pair means 2 dice, 6 square 36 and event is sum 4. So sum 4 corresponds to favorable outcomes, that is the numbers on the top faces of the 2 dice when the pair is rolled one time. 1 comma 3, 1 plus 3, 4. 2 comma 2 outcome, 2 plus 2, 4. 3 comma 1 outcome, 3 plus 1, 4. That is, these three are the favorable outcomes to the event sum 4. Now, so this game is played thrice, 3 times. Okay, they're asking exactly 2 of the 3 items. Items means that pair of dice rolled 1 time. So let E is equal to, I am applying binomial distribution, probability of getting sum 4 in any roll of pair of dice. That is first time, second time, third time, any roll of. So 3 favorable outcomes out of total outcomes 36. So this is 1 by 12. Implies Q is equal to probability of not getting sum 4. So that is 1 minus P is equal to 11 by 12. So N is equal to number of independent trials. Trial means performance of that experiment, that is rolling pair of dice. So 3 times, thrice. So here random variable. Let X be a binomial random variable denote number of times that sum 4 let X be a binomial random variable denote that number of times obtaining sum 4. Okay. Implies X is a discrete random variable, binomial random variable 0, 1, 2, 3. So therefore, probability of sum 4 obtains exactly 2 of the 3 attempts is nothing but probability of X is equal to 2, which is nothing but this probability 3C2, that is NCX into P power X into Q power N minus X. P is 1 by 12 whole to the power 2 into Q means 11 by 12 whole to the power 3 minus 2 is 1. Okay. So this is simplifies to 3C2 value 3 and numerator 11, 12 cube value, you know that 144 into 12, that is 1728. So finally it simplifies to 11 by 576 approximately 0.019. Okay. This is end of the question. The question is, the function f of x comma y satisfies the Laplace equation del square f of x comma y is equal to 0 on a circular domain of radius r is equal to 1 with its center at point P with coordinates x equal to 0 comma y is equal to 0. The value of this function on the circular boundary of this domain is equal to 3. The numerical value of f of 0, 0 is. This is from engineering mathematics, from the topic applications of partial differential equation. That is, main topic is differential equations. The solution is, so already given f of xy satisfies the Laplace's equation. Circular domain means, so the domain means region. The region is in the shape of circle having radius r is equal to 1, center is equal to 0, 0. Okay, so that is given. Since f of x comma y satisfies the Laplace's equation del square f is equal to 0 on a circular domain of radius r is equal to 1 with center at 0, 0. Okay, so this function satisfies the Laplace equation at every point on the circular region. Domain means region. Radius r is equal to 1 and the center at 0, 0. Okay, so and already on the boundary of this circle, the function value is equal to 3. That means inside the region also at every point the function value must be equal to 3. That is, the function is a constant function. And value of f of x comma y is 3 for all points x comma y on the circular boundary of this domain. So on the boundary of the circular region, that is circular domain, it is given function value 3. Already function satisfies the Laplace equation on the circular domain, that is circular region. So that means inside the points of this region, the function satisfies the Laplace equation. Already the function value is equal to 3, means the same function value is also equal to 3 at interior point of the region. Okay, so that is, okay, f of x comma y is equal to 3 is a constant function. Okay, is therefore f of x comma y is equal to 3 is a constant function. You know that constant function means for every point the function value is 3 only. That is, all the points are mapped to a number 3 only. Okay, so hence f of 0 comma 0 means any point on the circular region, automatically the function value is 3. Okay, so the answer is 3. Accordingly, the option C. This is end of the question. The question is integral x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus etc. dx is equal to 4 options given. This is from engineering mathematics from the topic calculus integration. Solution. So let us evaluate this integration. This is an infinite series expansion which is log 1 plus x. We'll do term by term integration or log 1 plus x integration using integration by parts and check that one by one option, whichever satisfies, that is the answer. So first, integral x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus etc. dx. X integration is x square by 2 minus x square integration x cube by 3, that is simplify 6. X cube integration x power 4 by 4, 4 into 3 12. X power 4 integration x power 5 by 5 into 4 20 plus etc. Okay, now option A 1 by, so adding plus constant, C is constant. After integration, indefinite integration, after integration, after the completion of integration, add the arbitrary constant. 1 by 1 plus x is equal to, I can write 1 plus x whole power minus 1. This simplifies to 1 minus x plus x square minus x cube plus etc. Okay, so this is not equal to the given integration. Okay, B 1 by 1 plus x square can be written as 1 plus x square whole power minus 1 is equal to 1 minus x square plus x square whole square minus etc. This is nothing but 1 minus x square plus x to the power 4 minus x square, which is not equal to the given integration, the value of the given integration. C minus 1 by 1 minus x is equal to minus of 1 minus x whole to the power minus 1 minus of 1 plus x plus x square plus x cube plus so on. This is also not equal to the value of the given integration. D minus 1 by 1 minus x square is equal to minus of 1 minus x square whole to the power minus 1. So this is minus of 1 plus x square plus x power 4 plus etc. So this value is also not equal to the value of the given integral. Okay, so here remember the two expansions, 1 minus x, since whole power minus 1 is equal to 1 plus x square plus x cube plus so on, and 1 minus x whole power 1 plus x whole power minus 1 is equal to 1 minus x plus x square minus x cube plus so on. So that means all the given options are not satisfied. Okay, therefore all options are not satisfied. Therefore, all options are not satisfied. That is, the value of the given integral is not equal to any one of the options. Okay, so marks to all students this problem. So the question is, P and Q are two square matrices of same order. Which of the following statements is are correct? This is from engineering mathematics from the topic linear algebra basics. So the solution is, we know that AB whole inverse is equal to B inverse A inverse whenever A and B are invertible. Okay, since AB whole inverse is equal to B inverse A inverse, okay, and BA whole inverse is equal to A inverse B inverse. If A and B are invertible matrices of same order. Okay. So therefore, if P and Q are invertible, then PQ whole inverse is equal to Q inverse P inverse, and QP whole inverse is equal to P inverse Q inverse. So AB satisfies. C is not satisfying. C is not true. C is not correct. AB correct. D. Whenever not invertible, AB whole inverse not equal to B inverse into A inverse. Okay. And P comma Q are not invertible, then PQ whole inverse not equal to Q inverse P inverse. So therefore, A, B, these are two only statements correct. Therefore, A, B are correct. Okay. So this is the answer. A, B statements. This is end of the question. The question is, the error in measuring the radius of a 5 centimeter circular rod was 0.2%. If the cross-sectional area of the rod was calculated using this measurement, then the resulting absolute percentage error in the computed area is. This is from engineering mathematics and one of the technical subject also. Okay. And from the topic calculus, subtopic that is derivatives, the solution is, actually this is from technical subject, but we can do the same problem in mathematics also, just from 11th 12th standard approximations and errors. So circular rod cross section means automatically it is a circle having radius r, area, you know that all this. Let r comma a be the radius comma area respectively of a circle. Okay. Then this r is equal to 5 delta r by r into 100. That is percentage error given 0.2. Okay. And area A is equal to pi r square. So this means, what is this circle? Cross sectional. Area of rod. Okay. Now they're asking percentage error in the computed area. This is. So taking both sides delta, which is the increment in A. So this is delta of pi r square, just like differentiation. This is delta A means error in A. So pi into 2r r square delta change in r square becomes 2r delta r, error in r square, that is. Now this implies delta a by a into 100 is equal to 2 pi r delta r, a means pi r square into 100. So this is equal to 2 into delta r by r into 100. So this is equal to 2 into delta r by r into 100, already given 0.2. So this is equal to 0.4. Absolute means that is taking modulus. Here we already got this delta a by a into 100 is 0.4. So its absolute also 0.4. Therefore, the absolute percentage error in the computed area is 0.4. So the answer is 0.4. This is end of the question. Question is, consider the polynomial fx is equal to x cube minus 6x square plus 11x minus 6 on the domain S given by 1 less than or equal to x less than or equal to 3. The first and second derivatives are f dash x and f double dash x. Consider the following statements. 4 statements given, 4 options given. This is from engineering mathematics from the topic calculus, maxima, minima. The solution is now here domain S is nothing but 1 less than or equal to x less than or equal to 3. This is nothing but closed interval 1 comma 3. Okay. So this is the domain. Domain in inequality is given. So it is a closed interval a comma b. Okay. Now let us check the 4 statements. F of 1. Put x is equal to 1 in the fx. 1 minus 6 plus 11 minus 6. 0. Put x is equal to 3 in fx. 3 cube 27. 6 into 3 square 54. 11 into 3 33 minus 6. So this is 60 and this is minus 60 will become 0. So therefore, given polynomial fx value f of x is equal to 0 at the boundary points x is equal to 1 comma x is equal to 3. Therefore, statement 1 is correct. Okay. Now, first derivative f dash x. 3x square x cube derivative, 6x square derivative 12x, 11x derivative 11. For local maximum minima, the necessary condition is first f dash x equal to 0. Okay. That is, we have to find the stationary points. F dash x equal to 0 gives 3x square plus minus 12x plus 11 equal to 0, which is a quadratic equation x. So x is equal to minus b plus or minus square root of b square minus 4ac by 2a. So 12, a value 3, b value minus 12, c value 11 plus or minus b square, that is 12 square 144 minus 12 whole square. Minus 4 into 3 into 11. So that is minus 132 by 2 into 3, 6. Okay. So this is 12 plus or minus 144 minus 132 is 12. Under square root 12 we can write 4 into 3. So 2 root 3 by 6. Now this is separating the term. 12 by 6 is 2 plus or minus 2 by 6 with 1 by 3 into root 3, and that 3 can be written as root 3 into root 3. 1 root 3 cancelled. After that, we'll be getting this is 1 by root 3. So finally, 2 plus or minus 1 by root 3. Okay. So two stationary point. But see that domain S is 1, 2, 3 only. 2 plus 1 by root 3. Okay. Root 3 value 1.732. So 1 by 1.732 is a fraction value lies between 0 and 1, proper fraction. So 2 minus 1 by root 3, 2 plus 1 by root 3, both belongs to the given domain S. Okay. So finally, x is equal to, or you can write here directly. Okay. Two plus 1 by root 3, comma 2 minus 1 by root 3 belongs to the given domain S, comma, or the stationary points. Okay, at each stationary point, find second derivative. If second derivative greater than 0, local minima. Second derivative less than 0, local maxima. Now second derivative is 6x minus 12. Next, f double dash x. This is 6x minus 12. Now at x is equal to first stationary point, 2 plus 1 by root 3. Okay, implies f double dash x is equal to 6 into 2 plus 1 by root 3 minus 12. 6 into 2, this 12 cancelled. 6 by root 3 greater than 0. And at x is equal to 2 minus 1 by root 3, comma, f double dash x. This is 6 into 2 minus 1 by root 3 minus 12. In place of x, put x is equal to 2 minus 1 by root 3. So this is again minus 6 by root 3 less than 0. So therefore, f of x has local minima. This is okay. At x is equal to 2 plus 1 by root 3. Okay. And local maxima at x is equal to 2 minus 1 by root 3. So that means fx has one local minima at x is equal to 2 plus 1 by root 3 and one local maxima at x is equal to 2 minus 1 by root 3. Okay. Now, so what is another statement given? The second derivative f double dash x greater than 0 throughout the domain S. That means for all x values in the interval 1, 2, 3, closed interval 1, comma 3, is f double dash x greater than 0. So one of the stationary point, that is 2 minus 1 by root 3 f double dash x, we got less than 0. Okay. So since f double dash x less than 0 for x is equal to 2 minus 1 by root 3 belongs to S. Okay. Therefore, f double dash x f double dash x not greater than 0 for x is equal to 2 minus 1 by root 3 belongs to S. Okay. So therefore, statement 3 is not correct. Therefore, 1, 2, and 4 are only correct. Okay. So accordingly, the option B is the answer. This is the end of the question.